Welcome to 4.2 part 2. We're still factoring quadratics, so let's pound through this warm-up quickly. And this isn't going to take us too terribly long today. So foiling each of these, x squared, we're going to get plus 7xy, then minus 7xy. And those, of course, will cancel. And then minus 49y squared. And of course, when you write it simplified, you see that it is clearly a difference of squares, which we are used to factoring. Similarly here, this is going to be a difference of squares as well. Once it's all foiled out, 0.9 times 0.9 is 0.81. And x squared, then we're going to get 0.63 minus 0.63xy. No, not xy, just x. And then plus 0.63xy. No, not xy. Just x. And then minus 0.49. And of course those can be cancelled out and we get 0.81x squared minus 0.49. On to the next one. 3m times 3m is 9m squared. Here we're not going to have a difference of squares because these signs are the same. So we're going to end up with minus 3m and then minus 3m again and then plus 1. So we get 9m squared minus 6m plus 1. Over here, again, same sign, so this is not going to be a difference of squares. 0.4 times 0.4 is 0.16, and that'll be x squared. And then plus 0.20xy, that's from this, and then from this, wait, no, that's from that. And then plus another 0.20xy, and then plus 0.25y squared. So 0.16x squared plus 0.40xy plus 0.25y squared. Okay, x squared plus 4x minus 6x minus 24, which leaves us with x squared minus 2x minus 24. X squared plus 5x plus 8x plus 40 leaves us with x squared plus 13x plus 40. There you go. Solving quadratic equations using factoring. So let's just factor these. First step, always look for a greatest common factor. Okay, this is the first thing you should be doing for every factoring problem. 3 will come out of every one of these things. Okay, now this isn't an equation. It's not set equal to 0 or anything else. So we can't get rid of any factors. They have to remain as part of the expression, but we just write them outside of the brackets. So divide everything in here by 3, and that's what you'll be left with. Now, sum and product. Your sum is going to be plus 1, and your product is going to be minus 2. So the factors of minus 2 are 2 and minus 1, minus 2 and 1, and that's it. Pick the ones that add up to positive 1, and that would be these two. So you go 3 times x plus 2 times x minus 1. And we're done. All right, B. It always helps to take out the coefficient in front of the squared term, the quadratic term. So take out your a value. Now if we take out a half, that'll leave us with x squared here. Basically we're dividing each one of these things by 1/2. And when we divide by a half, so this is -1. -1 divided by a half is the same as -1 times 2/1. So you flip the denominator and multiply. And this would be -2. So this will end up being minus 2x. So you can see that everything, when we divide by a half, everything just doubles. And this will be -8. You can confirm using this method if you like. Okay, now our sum is -2 and our product is -8. So factors of -8 include -8 and 1, -1 and 8, -2 and 4, and -4 and 2. And we need to pick the two that add up to -2. These add up to -7, +7, +2. These ones are the correct sum. So we go x minus 4 times x plus 2. Alright, last one. I'm going to leave you to do it on your own, and then you can come back and check your answer in a second. So here's your answer. Hopefully you identified this as a difference of squares. This is a perfect square, as is that. 36 is a perfect square, and so is k squared. So there you go. We'll do A together, and then I'm going to hit pause and ask you to try B on your own, and you can come back for the answers. So A, we need to factor each polynomial. The unfortunate thing is it hasn't even been expanded yet to be able to be factored. So we need to do all that first. So we need to square this term, then distribute the -2 in, then distribute the 12 into here, and then group all of our like terms together. So let's start by squaring the n plus 3 term. N plus 3 all squared is n plus 3 times n plus 3, which will leave us with n squared plus 6n plus 9. Now of course the -2 has to be distributed into this whole thing. So we get minus 2n squared plus 6n, no, minus 12n, oh, minus 12n, minus 18. Your next term, plus 12n plus 36. And then finally, plus 14. Now we need to group all of our like terms, and there are no other squared terms, so minus 2n squared remains unchanged. Minus 12n plus 12n, those are gone. Minus 18 plus 36 is positive 18. Positive 18 plus 14 would leave us with positive 32. Now we need to factor, so take out a greatest common factor, or the a value, the coefficient in front of the quadratic term, and that will leave us with n squared minus 16. And now inside the brackets here we've got a difference of squares. Perfect square, separated by a minus sign, so this is n minus 4 times n plus 4. And we're done. Okay, when you come back, I'll have the answer up for part B, so go ahead and hit pause now. Okay, so here's your answer. This was a bit of a sneaky one. The idea is to recognize this as a difference of squares. So this is a perfect square, as is 4. 0.25 is a perfect square, as is y minus 4 all squared. So we take 4 times x minus 2 all squared as our a squared value, and we take 0.25 times y minus 4 all squared as our b squared value. Therefore, a is 2 times x minus 2, and b is 0.5 times y minus 4. And then we go a minus b times a plus b, and that's how we factor our difference of squares. There you go. So here are a couple more your turns. We're going to do A together, then I'll get you to do B and C on your own, and I'll display the answers for you. So this one, now we have equations. You can see that there's an equal sign in them, and they're set equal to 0 in each case. So let's start by factoring. We're going to learn about something called the zero product property here. So x squared minus 10x, so there's your sum. Your product is plus 25. Now, in order to have a negative sum, we need some of our factors to be negative. But we have a positive product, which means we need both of our factors to be negative. So, the factors of 25 are negative 25 and negative 1, or minus 5 and minus 5. Pick the two that add up to minus 10. That, of course, is those two. So we go x minus 5 times x minus 5 equals 0. Now, the zero product property states that if either one of these sets of brackets is equal to 0, since we're multiplying them together, they would both, the whole equation would reduce to 0. So the x value that would make the first set of brackets 0 is 5. The x value that would make the second set of brackets 0 also happens to be 5. So your answer is x equals 5. This is the value that makes this statement true, or makes this equation true. Another way to do it is to just take each one of these independently and set them equal to 0. So we go x minus 5 equals 0, and then you add 5 to both sides, and we go x equals 5. And of course it would look exactly the same if we did the other one. I changed my mind. I'm going to do B with you and then just allow you to do C on your own, just so we can look at one that has a bit of a different look. Actually, scratch that. I'm going to do C with you and allow you to do B on your own. So with C, we have a coefficient in front of the quadratic term, but we cannot take it out of these last two terms, so we have to find another way to factor. So your product is going to be 3 times negative 8, which is negative 24. Now, the factors of minus 24, we need to choose two that add up to minus 2. So there's negative 24 and 1, negative 1 and 24, negative 2 and 12, and negative 12 and 2, negative 3 and 8, negative 8 and 3, negative 4 and 6, and negative 6 and 4. And there we go, the last one we look at has the correct sum that we're looking for. So we go 3x squared minus 6x plus 4x. So we just rewrite our minus 2x as two separate terms based on these values that we found here. Minus 8. Alright, and now we can use grouping to turn these into two factors. So take out a positive 3 and we get 3 times x squared minus, let's take out a 3x. So 3x times x minus 2. And then here we can take out a 4, and 4 would be times x minus 2 equals 0. So we have our two terms, 3x plus 4 times x minus 2 equals 0. Now we use our zero product property. So we set 3x minus 4 equal to 0. Add 4, so 3x equals 4. And then divide by 3, x equals 4/3. This is one of our roots. We also have a root from this term, so x minus 2 equals 0. Add 2 to both sides, and we get x equals 2. That's our second root, which means either of these x values, if we plug them in to our original equation, it would make this statement true. They would all add up to 0. So I'll give you a chance to do B on your own. Looks like it's going to be a simple difference of squares, so give it a shot. The answer will be on the page when you return. Hit pause now. Okay, so there are your answers. Hopefully you were able to come to the same conclusion. So here's the last one for this lesson. Oh no, it's not. Second last one. So let's go through the problem together. A water slide ends with the slider dropping into a deep pool of water. The path of the slider after leaving the lower end of the slide can be approximated by this quadratic function, where h is the height above the surface of the pool, and d is the horizontal distance the slider travels from the lower end of the slide. Both are measured in feet. What is the horizontal distance? So we're asked to solve for h, the slider travels before dropping into the pool after leaving the lower end of the slide. Alright, so basically what this looks like is we have a swimming pool here, and your water slide comes down and it goes eventually into the water like that. So this is the end of your slider. Now, what we want to figure out is how far we go horizontally this distance before the slider drops into the pool. So, when the slider drops into the pool, the height of the slider, h, above the surface of the pool, that will be 0. Alright, so this is all the information we need to solve this whole thing. So we just set the height above the pool equal to 0, and we want to find the horizontal distance, which is d, that we're actually going to be solving for here. So I'm going to remove this fractional coefficient in front of the quadratic term. That will leave us with d squared and plus d. Now if we divide negative or positive 2 by negative 1/6, it's the same as multiplying by negative 6, which will leave us with negative 12. And now this looks like something very familiar and easy to solve for. If we wanted to get rid of this coefficient here, we could divide both sides by 1/6, or multiply both sides by 6. Now 0 divided by 1/6 would just remain as 0. So this term, essentially, this coefficient can completely disappear, and we're left with something really simple. We can just look at our sum is plus 1 and our product is minus 12. So we're going to be looking at plus 4 times minus 3. So we get d plus 4 times d minus 3 as our possible solutions here. So d equals minus 4 and d equals 3. Now of course the slider cannot drop into the pool at a distance of minus 4 meters, okay, after it starts, because this would mean the slider hasn't started yet. So we don't take negatives when we're calculating a distance, so that answer we have to throw away. And this is your only solution. So your distance then is going to be 3 meters horizontally before the slider drops into the pool. Final question here. We're given the area of a ping pong table Ping pong table, of course, is rectangular. A equals length times width. So 45 square feet equals the length times the width. Now we're not given the length and width explicitly, we're just told the length is 4 feet more than the width. So if we call the width W, okay, then we got to multiply it by the length. We don't know the length, we only know how it relates to the width. It's the width plus 4 feet. So we would go times W plus 4. Now distribute this in here and it'll turn it into a quadratic. 45 equals W squared plus 4W. Now we have to get everything to the same side of the equal sign. Set one side equal to 0, so we subtract 45 and subtract 45, so we get 0 equals W squared plus 4W minus 45. Find the factors of minus 45 that add up to positive 4. So let's start with negative 1 and 45 and negative 45 and 1. Obviously that sum is way off. So I'm going to jump to minus 9 and 5 and minus 5 and 9. This is the one that gives us a sum of positive 4. So we go W minus 5 times W plus 9 equals 0. W equals 5. That was weird. W equals minus 9. Of course, the width cannot be negative 9 feet. It's impossible to have a negative width. So this is our answer. The width is 5 feet, which makes the length, we were told it is 4 feet more than the width. So we would just say the length is 5 plus 4, and the length equals 9 feet. And of course you can confirm length times width, 9 times 5, would leave us with the 45 square feet that we started with. Alright, that's all for today. See you in class tomorrow.